Alright, so we're talking about in the geometry book, section 3.3, which deals with parallel and perpendicular lines. Alright, so we're going to start with a picture, and our picture has three lines, and we're given A is parallel to B, and B is parallel to C, and we want to prove that A is parallel to C. So it should be kind of intuitively obvious if two lines are parallel to the same line, then they have to be parallel to each other, but we want to flesh out a proof. And so to do that, first let's just talk about what the overview of it is, how we're going to go about it, and then we're going to present it, and we're going to do a flow proof this time. Alright, so I want to draw a transversal, and the reason that I want to do that is because all of my theorems and postulates deal with the transversal and the angles that are formed by them. So I'm going to need to have that picture there. And then I'm going to use our theorems, and the one that I'm going to choose to use is the corresponding angles theorem, and or postulate. The reason I'm doing that is just because it's a starting point. It's an easy one to remember. We could use different ones, but it'll be simpler in our case if we just use the corresponding angles theorem. So we're going to do something called a flow proof, which is a different way to present things as opposed to a two-column proof, and we'll see kind of how that looks as we go through this. So there's my transversal, and I'm going to label angles 1, 2, and 3. And those are all corresponding angles, which is good because I want to use that postulate. Alright, so I'm going to start with my proof. I have A parallel to B, and that is given. I also have B parallel to C, and that's given as well. From those information, I can draw a conclusion that 1 is congruent to 2 by my corresponding angle postulate, and that 2 is congruent to 3 by my corresponding angle postulate. I can then conclude if 1 is congruent to 2 and 2 is congruent to 3, using the transitive property of congruence, I conclude that 1 is congruent to 3. And 1 and 3 are also corresponding angles, so I have a postulate that lets me conclude that A is parallel to C, and that's the converse of the corresponding angles postulate. Alright, so we've proven what we knew to be true, that if two lines are parallel to the same line, then they're in fact parallel to each other. Alright, another picture that we're going to look at deals with perpendicular lines. So if we're given that A is perpendicular to B and C is perpendicular to B, then we want to conclude something about A and C, and it's not that they're perpendicular, but that they're parallel. And so here a picture is worth a lot in trying to figure out why this looks the way it does. So if I have three lines, A, B, and C, and A and C are perpendicular to B, it's pretty intuitive as to why A and C are going to be parallel, but we still need to flesh out the reasonings with our flow proof. So I'm going to label some angles, 1 and 2, as corresponding angles so that I have some clarity when I'm moving my proof. And then we're going to use a flow proof again. So I was given that A is perpendicular to B and C is perpendicular to B. And from that I can conclude the measure angle 1 is 90 and measure angle 2 is 90, and that is due to my definition of perpendicular lines. So perpendicular lines form 90-degree angles by definition. Alright, well, if measure angle 1 is 90 and measure angle 2 is 90, I can conclude that measure angle 1 and measure angle 2 are the same. And I do that with substitution, and not the transitive property because of the way it's set up. If it was measure of angle 1 equals 90 and 90 equals measure of angle 2, that is set up as a transitive property. This is set up as substitution. So the measures are the same, which means that the angles are congruent. And that is due to my definition of congruence. If angles have the same measure, they are going to be congruent angles. Alright. Well, 1 and 2 are corresponding and they're congruent, which allows me to conclude that A is parallel to C. And that is from the corresponding angles postulate. Alright, so if I have corresponding angles that are the same, the lines are parallel. So again, if we have two lines that are perpendicular to the same line, they are going to be parallel to each other. Alright, so that is what Theorem 311 says. We just looked at a proof for it. And we're given an example here. So if we have that A is perpendicular to S and C is perpendicular to S, and A is perpendicular or parallel, to B, we want to prove that C is parallel to B. So we're going to fill in our statements and our reasons here. And we start with a given, and we also have that B is perpendicular to S. And how do we know that to be true? Well, from Theorem 311 above. If we have two lines that are perpendicular to the same line and they're parallel, then they're going to be perpendicular to S. Alright, moving forward, measure of angle 1 is 90, measure of angle 2 is 90. The way that we know that is our definition of perpendicular lines. They form 90-degree angles. Measure of angle 1 equals measure of angle 2 because of substitution. which means that they are congruent angles because of our definition of congruence. Well, if one is congruent to 2, and they're corresponding, then C is parallel to B because our corresponding angles postulate. So again, we fleshed out in our 2-column proof, if we're given A is perpendicular to S, and then C is perpendicular to S, and A is parallel to B, we conclude that C is parallel to B. We could have used our 2 theorems that we just proved, but this fleshes out another way to look at it.